Hello everyone! Welcome back once again to DOK GILMAC Online Tutorial, Grade 10 Mathematics Tutorial. The topic I will be discussing for today's tutorial is all about illustrating geometric sequence. Before discussing the topic for today's tutorial, let's have first a warm-up drills. Simplify the following expressions. Number 1, 4 raised to 3. This is just equal to 64. Number 2, negative 2/3 quantity raised to 3. This is just equal to negative 8/27. Number 3, negative 1/2 quantity raised to negative 2. This is just equal to positive 4. Number 4, quantity negative 2 raised to negative 3. Yes, it's equal to negative 1/8. Number 5, negative of quantity 3 raised to negative 4. Yes, it's equal to negative 1/81. Recognize and extend geometric sequences. Find the nth term of a geometric sequence are the two objectives of today's tutorial. Geometric sequence and common ratio are the two vocabulary we're going to encounter in this tutorial. What are geometric sequences? Geometric sequences can be thought of as functions. The term number or position in the sequence is the input, and the term itself is the output. What are geometric sequences? Consider the term or terms. So we have 4, 8, 16, 32, and 64. From here, we have the position or positions. So we have 1, 2, 3, 4, and 5. So from here, we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. These are all the 5 terms of this given geometric sequence. To find a term in a geometric sequence, multiply the previous term by R, which is the common ratio. So take note of that. Let's have example number 1. Find the next 3 terms in the geometric sequence. Consider 1, 3, 9, 27, and 81. So from here, we determine their common ratio. So as you can see here, 81 divided by 27 is 3. 27 divided by 9 is 3. 9 divided by 3 is 3. And 3 divided by 1 is 3. Or simply the first term multiplied by 3, we have the second term. Second term multiplied by 3, we have the third term, and so forth and so on. Finding the next term, we have this given formula. A sub n is just equal to A sub n minus 1 times R. Okay, so from here, since R is equal to 3, so we have the 3 next term in this given geometric sequence to be equal to 243, 729, and 2187. Simply, we have 81 times 3 is 243, times 3 we have 729, times 3 we have 2187. Let's have example number 2. Find the next 3 terms in the geometric sequence. Negative 2, 4, negative 8, 16, and negative 32. Let's have their common ratio. So as you can see here, their common ratio is negative 2. Finding the next term, we have the given formula, A sub n is just equal to A sub n minus 1 times R. So since R is equal to negative 2, so we have the next 3 terms to be equal to positive 64 times 2, negative 2 I should say, we have negative 128 times negative 2, we have 256. So take note of that. Take note, when the terms in geometric sequence alternate between positive and negative, the value of R is negative. So take note of that. Let's have example number 3. Find the next 3 terms in a geometric sequence. Negative 40, 10, and negative 5 over 2. Finding the next term, we use this given formula. A sub n is just equal to A sub n minus 1 times R. So the first thing we have to do here is to determine their common ratio. So from here, we have R is just equal to 10 divided by negative 40, or we simply have R equals negative 1/4. Therefore, from the values of R and the first term, we have the next 3 term to be 5 over 8, negative 5 over 32, and 5 over 128. To find the output A sub n of a geometric sequence when n is a large number, you need an equation or simply a function rule. The pattern in the table shows that to get the nth term, multiply the first term by the common ratio which is raised to the power n minus 1. So as you can see here in the given table, so we have the first column in words, first term up to the nth term. In numbers, 3 times 2 raised to 1 is 6. 3 times 2 raised to 2 is 12. 3 times 2 raised to 3 is 24. 3 times 2 raised to n minus 1. Okay, in algebra, we have a sub 1. And we have a sub 1 times r raised to 1. A sub 1 times r raised to 2 up to a sub 1 times r raised to n minus 1. So, as you can see here, we have the given formula in determining the nth term of a geometric sequence. If the first term of a geometric sequence is a sub 1, the nth term is a sub n, and the common ratio is r. So as you can see here, In this given formula, a sub n is just equal to a sub 1 times r raised to n minus 1. A sub n is the nth term, a sub 1 is the first term, and r is the common ratio. Let's have illustrative example. If the first term is equal to 5 and the common ratio is equal to 4, the fifth term is, so we use the formula, a sub n is equal to a sub 1 times r raised to n minus 1. So we have 5 times 4 raised to 5 minus 1, or we simply have 5 times 4 raised to 4. That is just equal to 1,280. So take note, the fifth term is just equal to 1,280. Let's have example number 4. Find the 10th term in the geometric sequence. So we have here 2, 4, 8, 16, and 32. Let's determine first their common ratio. So as you can see here, the common ratio of this geometric sequence is 2. So therefore, finding the next term, or simply the 10th term, we use this formula. A sub n is just equal to a sub 1 times r raised to n minus 1. Or we have a sub 10 is just equal to 2 times r, which is just equal to 2 raised to 9. Since 10 minus 1 is 9. So therefore, since the following have common ratio, which is 2, a sub 10 is equal to 2 times 2 raised to 9 is just equal to 1,024. Let's have example number 5. Find the 10th term in geometric sequence. Okay? So we have 1, negative 3, 9, negative 27, and 81. So as you can see here, in this given geometric sequence, r value here is negative. So we have actually the value of r is negative 3. So therefore, from here, we can be able to determine the 10th term using this formula. A sub n is just equal to a sub 1 times r raised to n minus 1. So we have 1 times negative 3 raised to 9, or simply equal to negative 19,683. Again, I would like to thank you for watching. Stand by for my next tutorial, and may God bless us all.